Hello, my name is Jonathan Sundy. I'm Strato's Chief Engineer for Draft Systems, and we're going to talk about why preload is important in a draft system. As a train goes down the tracks, it is subjected to a wide range of loads and forces. The train is not a singular body, but rather made up of many individual units. Longitudinal forces can cause the consist to behave like an enormous rubber band. As it ascends a grade, the tractive effort of the locomotive is fighting against gravity to stretch the train out tight. As the consist descends a grade, dynamic braking is now resisting that gravity to bunch these cars back up together. This can be pushed even further by an emergency brake application. To look closer at the impacts of this dynamic behavior, we'll focus on the connection between just two of the cars in the consist. These two cars have some level of freedom to move in relation to each other. This freedom is constrained by the resistance of the draft system in the ends of the cars, with higher levels of resistance being better for over-the-road train action. The draft system is composed of individual components as well, which will have some loose connections referred to collectively as free slack. There is up to an inch of slack that exists between two couplers alone. As you look deeper inside the car, the individual components of the draft system all have their own freedoms. Hydraulic end-of-car cushioning can have over 2 inches of free slack when they're brand new. All of this free slack increases component wear on an individual basis, but on a larger scale, the main problems arise the moment the slack runs out. As we move down the spectrum of draft system preload, the internal valving of a hydraulic end-of-car cushioning unit acts like a wall protecting the sensitive lading from the ongoing tides of in-train forces. As waves of low-spectrum forces are transmitted through the consist, this preload prevents any movement beyond the free slack already in the system. But once conditions allow for a wave that's just strong enough to overcome that preload, you're underwater. Some hydraulic units are tuned for softer impact performance. In this situation, some of those smaller force waves will have enough power to overcome this lower preload. But the ramped force application of Strato's Selective cushioning unit serves as more than a single barrier against in-train forces, protecting sensitive lading from any level it might see. As I said at the beginning, my name is Jonathan Sundy, and I am Strato's Chief Engineer for Draft Systems. Remember to contact myself or your local Strato sales manager for more information on this project or any of Strato's other solution-oriented product lines. Thank you.